Sorry, I was on mute. Hi, everybody. Welcome to Saturday Night SQL Virtual Group webinar. My name is Sarah Huang. I'm the founder and organizer of this virtual group. Join me here is Adam Zga. He will jump in if I get disconnected. Today, Brent Ozar will present Getting Better Query Plans by Improving SQL's Estimates. I'm sure many of you have listened to Brent Ozar's presentations before. Brent Ozar loves to make SQL Server faster and more reliable. He created SP Blitz and the SQL Server First Responder Kit. He loves sharing knowledge at brentozar.com. We really appreciate Brent share his knowledge with us on Saturday night. Let me first go through a few slides from past, then I'll transfer screen over to Brent. If you could, please register for past summit. If you register before September 22nd, you'll be able to secure the best possible price for the summit. As a member of SQL Saturday virtual group, you can save $150 of your past summit registration fee.
Sarah, I don't think your screen is being shown here.
Oh, I'm sorry. Thank you. Can you see it now?
Yes.
Okay, cool. So to register to save $150 for the registration for the conference, past summit conference, the code is VGDISP9II. PASS has a Passion Award nomination opens until September 28th. If you know someone who is a volunteer who has made an exceptional difference in the past community and deserve to be recognized, please nominate them now. On September 20th, there's a past marathon called Summit Solutions Preview, which provides you with the opportunity to preview the tools and services you have been wondering about using, ask questions to engineers and product managers without sales pitch, make plans for whom you want to visit at the past Summit exhibit hall. At the bottom, this is the registration link. If anybody needs this link, please ping me, post it on the chat window. The next session of past Facebook Live pop-up expert will be hosted by Kaylin Delaney on September 27th. And you can follow over here with this. And PASS is still looking to connect with new sponsors. For more information, you can reach out to PASS sponsorship team at sponsorship@pass.org. And PASS has a career center for employers looking for new talent, technical talent, and job hunters. These are the upcoming virtual group webinars by different virtual groups. I have to mention that they post our virtual group session. The title is wrong. I'll correct it when it's the time now. Send out an email to the entire virtual group members. And as you may know already, PASS has many virtual groups in different fields and languages. As always, you are more than welcome to join our virtual chapter virtual group, which is called Saturday Night SQL. These are the upcoming SQL Saturdays, at different places. I would highly recommend you guys to attend those near you. And you can, well, this is the benefit to join PASS. You grow your career if you are DBA, developer, data architect, analyst, and as well as IT professionals. And this is how you connect with the PASS through Facebook, Twitter, LinkedIn, and Instagram. This is how you may ask questions during this webinar. You can raise your hand if you'd like to interact directly with the brand, or you can write your question in the chat window and we'll ask your question on your behalf. Now I'm gonna transfer screen over to Brent. Brent, which account would you want me to transfer it to?
Oh, I can switch it over. The one without the microphone. Let's see here. I think I can switch it over to it. Here we go. Let's see if we can get that thing to go. It should be showing my slide deck now. Yes, there we go. All right, cool. Well, thank you. Thank you very much. Hi, folks. This is normally I present with a webcam on, so I'm like constantly looking at my own picture in the webcam, so I get all animated and happy. But now y'all will just have to imagine me happy because you don't actually get to see me. So I'm Brent Ozar, co-founder of Brent Ozar Unlimited. We're a little boutique consulting firm that specializes in high performance, highly available SQL servers. And everything that I'm going to talk through today, all of the slides, the demo scripts, all of it is available over at groupby.org/go/estimates. This is a presentation that I've been giving a few times online now, and I'm getting ready to work towards a different version of it for the PASS Summit. I'm super excited about the PASS Summit too myself. When you look at an execution plan in SQL Server, when you're looking at all the little arrows flowing around and the little operators and how much work that they do, SQL Server has to estimate how much work it's going to do for every part of a query. And it turns out that guessing the right number of rows that are going to come back from different parts of a query is really hard. And when SQL Server gets it wrong, things perform poorly. When those estimates versus actual rows, we're going to look through a few of them on an execution plan. When those estimates versus actual rows are reasonably close, and when I say reasonably close, I mean like 1x, 5x, sometimes even 10x off. To me, that's reasonably close, and you'll see why. When your estimates and actuals are those reasonably close, you're probably getting a good plan that accurately reflects how much work SQL Server is going to have to do in order to build those query results. Now, your query might not be fast. Maybe you're pulling back 1 billion rows or you're writing 1 billion rows into TempDB. But as long as SQL Server knows that you're going to write 1 billion rows into TempDB or whatever horrible idea you come up with, then at least SQL Server budgets the right amount of work to do. It budgets the right number of cores, the right amount of memory. It decides accurately to do whether it's going to do seeks versus scans. But when the estimates are nowhere near actuals, like they're 100x off, they're 1,000x off or more, that usually means you're getting a bad plan. Again, it doesn't have anything to do with slow or fast. It's just a plan that doesn't accurately recommend or doesn't recognize how much work your query is going to do. Because SQL Server may overestimate. It may go, oh my God, I think I'm going to bring 1 billion rows back. In actuality, it only brings 4 back. Sometimes it's insanely fast, but it just has side effects on the rest of the server. What we're going to do is we're going to have you build a guess on how many rows are going to come back from different parts of a query. We're going to start with a really simple demo. Now, I do need to give a little bit of word of warning. I use max.1. This is a query hint in this demo. This is not necessarily a good practice. It's just that I like to keep the execution plan really, really simple. The answer to making this query go faster, it doesn't have anything to do with that hint. It's just that I want to keep the query plan simple for easier explanation of what's happening to SQL Server's estimates. Now here's the query that we're going to be dealing with. I'm going to be working in the Stack Overflow database. You've probably seen stackoverflow.com. It's the site where you post questions and other people do all the hard work and you get to take the credit at the office. The users table at Stack Overflow holds exactly what you think it holds. The list of people who've ever asked a question or posted an answer over at stackoverflow.com. So what I'm looking here for this query is, go show me the most popular locations in the Stack Overflow database. Location being like wherever that user is from: Indiana, India, Lexington, Kentucky, Brooklyn, New York. People can type in anything that they want inside the location field. I'm going to try to ask SQL Server to come up with the most popular locations. Now, one thing I need to explain to you before we dig into SSMS is that everything inside SQL Server is stored in 8K pages. See the one piece of paper on the screen here, this one 8K page. This is the first page in the user's table. Everything in SQL Server is kind of sort of stored in, you could almost think of them as spreadsheets. In this case, our clustered index is on the ID field, starts at 1 and goes up to a bajillion. And the clustered index has all of the fields on it. You can see the time when the user was created, what their display name is, the last date that they accessed Stack Overflow. And then here's their location over on the right-hand side: Jeff Atwood, El Cerrito, Jeff Dalgas, Corvallis, Oregon. People can type in anything that they want inside these location fields. You notice this person's just put in IT for Italy. This person's just put in AU for Australia. You can put in anything that you want here. And you know how it is when human beings are going to go enter stuff into a database. You have no idea what they're going to put in. People can put at your mom's house or under the basement, anything that they want to put in for their location. So SQL Server is going to have a hard time guessing how this is going to work, how many rows are going to come back. Let's go pop into SQL Server Management Studio and go take a look. Now I have SQL Server 2017 here, but everything I'm going to show you today is the same, going back through the sands of time, going back through like SQL Server 2000 and before. There's no new concepts here involved in this. I've got the Stack Overflow database, and here's my query that I'm going to be executing. I have, like all of you have, I'm sure, a stored procedure to go drop all of the indexes in my database, just because I want to make it crystal clear that we only have that clustered index and nothing else. I'm going to say, go find out how many users are in the table, period. I want to tell you this so that you have a rough idea of how many users that you're dealing with. There are this many users in the database, and I'll put the commas in to make it a little bit more obvious there. We got about 5.3 million users in this copy of Stack Overflow's database. So when SQL Server goes to run this query, when it says, go find the most popular locations, the first thing that it's going to go do is build an execution plan. And I'm going to show the estimated execution plan first so that we can see what SQL Server's estimates look like and why we're going to run into problems. So here's our execution plan, and you read your execution plans from right to left. You read them in the rows that the arrows flow. The top right thing, the clustered index scan, this is the first thing that SQL Server did. It's going to do a few other things, and I'm going to talk through them. But the first thing it does is it goes and scans all 5.3 million rows. I love these little icons because they kind of explain exactly what SQL Server is doing, except I don't really like this one icon at all because the 3 prongs, it looks like one of those head massagers that you buy at the airport, like a little wire thing that you put on top of your head and move it up and down like it's going to give you a skull massage. I'm like, I don't really understand where this comes in. It's either that or it's a car gear shift, but generally speaking, I like most of the icons. What it means is it's going to scan from one side of the table to the next. It's just going to scan through the whole entire object. And if I hover my mouse over there, you look down near the bottom, it says estimated number of rows. And there's 2 right next to each other that are a little confusing. Estimated number of rows red and estimated number of rows. Estimated number of rows is how many rows SQL Server thinks are going to come out of this. There's going to be 5.3 million users. And if you look way down at the bottom, it says output list, and the only field there is location. What SQL Server is doing is it's scanning this entire table, and then it's just yelling out a list of locations full speed. Chicago, Italy, London, New York, Tokyo. This arrow is just a list of 5.3 million locations yelled at high speed to the next operator. Now that 5.3 million, it's pretty bulletproof. That estimate is going to be pretty good because SQL Server knows roughly kind of sort of how many rows are in the table. It's got a pretty good idea. But now the fun work starts because see, we wanted them grouped by location. So that's exactly what SQL Server is doing here with these little icons. This is for every one of those little rows coming in, we're going to put it into a bucket. Now, I wish in a perfect world, the little rows were coming from the right-hand side because they're coming from over here. They're not coming from the left, but whatever, we're pretty close. So the rows are going to come flying into here, and these are all of the locations flying in. So Chicago, have I seen that before? Nope, put it in a list. Philadelphia, have I seen that before? Nope, add it to the list. Chicago, have I seen that before? Yes, okay, put that back in the same bucket as the other Chicago users. We're just going to kind of group them all together. If you hover your mouse over this hash match, down at the bottom, it says output list. Output list is location, then expression 1005. Can kind of think of that as a count. It's not that expression 1005 always equals a count. Expression 1005 could be anything. It's just that's what it means in this case. So SQL Server is grouping them all together by location. And then look at estimated number of rows. Estimated number of rows, 4,075. SQL Server believes that 4,075 locations are going to come out of this bucketized list. Now that's kind of interesting. There are 5 million users in the database, and yet SQL Server thinks there's only going to be 4,000 locations. You and I know better than that because if we just look at the contents of the locations, you know that they're entered by human beings. They could be anything, but SQL Server doesn't know that. More on that in a second. The next thing that SQL Server is going to do is it's going to come up with a new count value. You see the little compute scaler and the little calculator. That means calculate a new value from something that we already know. And then it's going to turn around and it's going to sort all of that data. If you look down near the bottom, it says sort by expression 1002 descending. That happens to be the count star. You'd have to go through all kinds of properties menus in order to figure that out, but that's okay. We're going to sort by which ones are the most popular descending, and then the end result, we're going to have 4,075 locations sorted from A to Z. That's where the estimated number of rows comes from, all the way back at this hash match operator, where SQL Server believed, as it put people into different buckets by location, that it would have 4,075 come out. Now, where did it get the number 4,075? In this case, it flat out made the number up. It had no idea because I just got started with this database. I restored it. I dropped my indexes. All I have is the clustered index and nothing else. When SQL Server goes to execute this query, it has no idea what the contents of the locations are going to be. So when I go to run this query, and in order to run it, I'm going to say include the actual execution plan because I want to be able to see the numbers before and after. Let's go hit execute. SQL Server is going to go do its work. This is not a big table. It's only about 1 gigabyte in size. If I go look at the execution plan, now I'm looking at the actual plan. And you know for a couple of reasons. One is that I have a results tab. It shows me how many results I ended up with. The other reason you can tell is I have some yellow bangs here on some of these operators. You only get yellow bangs like this. Well, there's some yellow bangs that you get on an estimated plan. But on this sort and hash match, the only time I'm going to get those yellow bangs is when I run an actual plan. Let's repeat this process. We're going to read this plan from the beginning to the end. I'm going to hover my mouse over the clustered index. Now, this is where the tooltips get a little frustrating because some of the things on this tooltip say actual and some of them do not. And they're not really organized in any kind of order. It's almost like Microsoft loaded up the data paintball gun and just splattered the data all over the screen. Really wish they would even put in things like commas. It's not like commas are expensive, but whatever. Estimated number of rows, 5.3 million. Actual number of rows, 5.3 million. I really prefer hovering my mouse over these arrows here because it's even more concise and easy to see. We can see that the first estimate SQL Server had in terms of the number of rows that would come out is accurate. What about this one? What about with the hash match? Did it accurately estimate how many rows were going to come out of this? Nope. It's more than 10x off. It estimated 4,000 rows would come back. In actuality, 58,000 rows came back, quite a bit more. And unfortunately, if I hover my mouse over this hash match, see down at the bottom the warnings. Operator used tempdb to spill data during execution. I was granted 2 megabytes of memory and I used most of that. What happens is when SQL Server first starts running your query, it guesses how much memory it's going to need. It says, I believe I desire about 2.6 megabytes worth of RAM in order to run this query. So I'm going to request 2.6 megs of RAM and I'm actually going to get it. I got all 2.6 megabytes of RAM. Unfortunately, I used that. And then when I ran out, SQL Server doesn't magically give a query more memory, which I always find kind of funny because it's not like this is a small box. This is a virtual machine with 8 gigs of RAM. SQL Server hasn't even used all 8 gigs yet. It's still only used a couple few gigs of RAM. This box could certainly use, or this query could certainly use more memory, but once this query's gotten granted a certain amount, that memory is set in stone. That's all this query is going to get. If you bring back more data than that, you're screwed. And that's exactly what happened here. SQL Server ended up spilling this thing to disk. Let me move this around just a little bit. SQL Server ended up spilling this thing to disk, writing to tempdb because its estimates weren't right. Because it thought it was only going to be doing buckets for 4,000 rows, and in actuality, 58,000 came back. Now, I kind of look at this as a data tsunami. I wish that these arrows had like an expected versus actual size difference so we could see when they're way off. But this data tsunami is going to be flowing up through the rest of this execution plan. And the rest of these operators, they don't stand a chance. Because this sort, look at estimated number of rows, he only budgeted enough memory to sort around, say, 4,000 rows worth of data. And in actuality, he's trying to sort 58,000 rows of data. So he drops and writes this stuff to disk again. He writes these same rows back out to disk yet again. We pay a second tempdb penalty on this query. And then the number of rows that come out, 58,000 rows. Now, what you might expect is that when I ran it once, SQL Server goes, oh man, whoa, hold on. We're spilling stuff to disk like crazy. Maybe the next time I better give myself some more memory. That's not what happens at all. I can go execute this again. And it writes to tempdb again and again. And I can keep hitting execute over and over, thousands of times over, and yet every single time, SQL Server is still going to end up spilling to disk twice in just one query. This is an impact of what happens when our estimates aren't right. When SQL Server doesn't estimate the right number of rows are going to come back for an operator, in this case, from the hash match operator. And it's fair because when I look at these users, select top 1000 star from DBO users, when I look at these users and I look at the location column, man, there's no way to predict what these people are going to put in. Now, I know when I'm working with a lot of clients, a lot of people will say, well, wait, why doesn't, if SQL Server isn't able to accurately guess how many rows are going to come back in a situation like this, why doesn't it just overguess? Why doesn't it guess, say, out of this hash match, 5 million rows might come back? Because after all, this is a list of 5.3 million locations. They could all be different. Why doesn't SQL Server guess 5.3 million rows? Well, then in that case, if it overestimated counts on every single operator, then you'd end up with every query wanting like 10 gigs, 30 gigs, 100 gigs worth of RAM in order to run. And it would be a hot mess. So SQL Server needs the most accurate estimates it can, and it's up to us to figure out how to give this thing more accuracy, what we can do to tell the database more about what it knows about the particular contents of a table. And sometimes people will say, well, I'd like to go through and create a statistic. Create statistic, stat, location on DBO users, location. They go, now, once SQL Server knows more, create statistics. Once SQL Server knows more about a given column, it's going to do a better job of estimating how many rows are going to come back, right? Well, no, not necessarily. We're still kind of screwed here in this case. SQL Server still underestimating the number of rows, so that's not really the answer. Another thing that people will do is, if I go over to Object Explorer here, I can right-click on the Stack Overflow database and go into Properties. You can look under Options, and there's this drop-down here for compatibility level. Now, for years, this was like that light switch in the hallway where you would flip it up and down and you didn't really know what it was connected to. You would just end up leaving it in random spots and going, well, it doesn't seem to matter which one it does. But starting with 2014, it matters a lot. Starting with 2014, this gives us a different cardinality estimator, which is a part of the SQL Server engine code that guesses how many rows are going to come back from each operator. Now you'll notice that I had it on 2017. I'm going to stick with 2017, and I'm going to show you that plan again one more time. We're going to go look at the estimated number of rows so that we can write it down. We're going to say SQL Server 2017 guessed 4,075 rows. So 2017, 4,075 rows estimated. Let's see how the old cardinality estimator does. Let's drop back and go into options. And instead of 2017, let's go back to 2012 and let's see how it was for Grandpa in the old days when he was running SQL Server. Let's run it again. It's not like it was any faster for Grandpa back in his days, and he still had 2 spills. And if I hover my mouse over this arrow, Grandpa thought that 4,094 rows would come back. So 2012, 4,095, was it? 4,090, yeah, 4 rows estimated. So we can see here that it's not like that cardinality estimator is going to be the one thing that always gets us across the finish line. Does it make a difference? Yes. Does it get you across the finish line? That by itself, usually no. People usually ask me then, okay, so Brent, what are you saying about the cardinality estimator? Should I use it or not? That's a whole separate discussion. Although this session is about getting the most accurate estimates that you can, I want you to know that this is an option, but of course, when you change this, it changes all of the queries in that database, not just the one that you're working on. If you want to flip back and forth between old and new cardinality estimators, you can. You can even not just change it at the database, but you can even change it with hints inside a query. You can say in a given query, give me an old legacy cardinality estimator versus a new one. But that's not going to get us across the finish line here. We need something better than that. So one thing that you can do that's better than that is create index IX location on DBO users location. This tells SQL Server, I want you to go build another copy of this index, another copy of the table, simply sorted by location. I showed you what the clustered index looks like earlier. That was 8K pages. that held all of the columns in a table. But here we're dealing with an index that's only on, say, location. This screenshot example is an example of an index on last access date, but in our example, it's going to be location and then ID, just a big long list of locations and nothing else. Now, when I go to run this query, two things are going to happen. Let's go look at that execution plan. One, it's using the index scan. So now it's using this non-clustered index instead of a clustered index. This is just the yelled list of locations. Again, SQL Server knows how many rows are going to come out of it, but now there's no yellow bangs. There's no yellow bangs on either of these operators. And this operator, in fact, is even different. Before, it looked like a bunch of buckets. Let's show you those two execution plans side by side so you can see what the differences are. On the top one, I'm going to say with index equals 1, meaning I want you to specifically use the clustered index on this table. That's not usually a good idea. You're about to see why. So let's zoom these both to fit so that we can see what's going on here. The top one is before when we were throwing our rows into buckets. And the bottom one now, that operator looks different. He's now called a stream aggregate. And you can kind of guess by those little running sum icons, the little running formula icons, that SQL Server now has data in order coming into this operator. This operator over here, the index scan, he's reading out the list of locations in ordered. Now they are ordered as they come into here, so we don't have to put them up into buckets. Now, not only are they ordered, which means that we don't need any memory in order to pull this off. It's not like up here where we had to have memory to write a separate copy of the table, the separate copy of those rows. Here with this stream aggregate, the stuff's already in order. So now look at estimated versus actual rows. And here I'll move over to the arrow. SQL Server accurately predicted how many rows were going to come in and out. It said, well, of course, I know that 57,986 rows were going to come back. As a disclaimer, I always use a guy's voice for SQL Server because he's dumb and he's stubborn and he refuses to ask for directions. Trust me, I got this, even though he doesn't usually got this. So SQL Server now, because of the benefit of the index, SQL Server has not only a sorted list, but it also has accurate statistics on the contents of that index. So if I look at the contents of statistics, I don't expect people to know this command. This is one of those rare oddball commands that presenters use just to show you the contents of what SQL Server knows about a given index. Here, SQL Server says, well, yeah, here's all the different indexes or all of the different locations, and it's not even all of them. It's just the top, say, 200 plus null, all the different locations that are inside that table index. Plus, I also know how many distinct different rows are in that range. So if you sum all of these up, SQL Server knows that there's a total of about 58,000 rows inside the locations index or distinct locations inside this index. So now when it goes to execute this query, those two things that happened, one was that the data is already sorted in order, and two, SQL Server knows how many rows are going to come back. So now you also don't have a yellow bang over this sort operator. SQL Server accurately sorts how many rows are come in and go out and knows how many rows are going to come out of here, all because of the magic of the index that tells it exactly how many rows are going to come back. It's amazing how useful indexes are. Indexes aren't just about reading less data. Indexes aren't about using less CPU, aren't just about using less CPU, but they're also about understanding exactly how many rows are going to come in and go out at any given time. Now, they're certainly not your only battle plan. Let me pop over in here. They're certainly not the only tool that you have in order to accomplish this goal, but your job as a query tuner is to figure out, are the inputs and outputs of each operator accurate? Does SQL Server accurately understand how much data is going to come in and go out? And is there any way that I can make its estimates more accurate, which will then help it choose the right tool for the given job? The next thing that I would ask, though, when I'm looking at a query like this is, to whoever sent in the query, hey, buddy, do you really need all of the rows? Do you only maybe need, say, one page at a time? Because I can also cut down how much work the application does or how much work the SQL Server does by changing how many rows it asks for. So for example, if I pop back over here and I'm now going to take my two queries, copy and paste. So I'm going to take my two queries. In both of these, I'm letting SQL Server choose the index, but now I'm also going to say top 100 in this one. The first one's going to get all 58,000 rows. The second one's only going to get the top 100. If I look at the execution plans, they sure look identical. At first, you'd say, well, if anything, the top one's even better because the top one doesn't have a little yellow bang. But there's a catch. I'm going to right click on this select. I'm going to go properties. I'm going to look at memory grant. SQL Server goes, oh, you know what? I would want about 6 megabytes of memory in order to execute this query. And I'm actually going to end up using about 5 megabytes of that. But look down at the bottom one. Look down at how much memory he needs. Oh, I need about 40 kilobytes. Whoa! He wants like 100x less RAM because he chose a more efficient way of doing sorting. This is sorting an entire data set. This is only sorting the top 100. So now instead of needing 6 megs of RAM, now we can get by with just 40K of RAM when we go through and do the top 100. This means that now I can have more queries running concurrently. It takes less setup time to allocate that memory. You know how some of us probably monitor page life expectancy and it goes up and down like a seesaw. When it plummets all of a sudden very quickly, it can be because a query wants a giant amount of RAM. I can easily show you demos where SQL Server wants tens of gigs of RAM in order to execute a query. And that, of course, has to come from somewhere. That's when your page life expectancy starts to crash. The more accurate I can tell SQL Server about here's how much I need and you can discard the rest, makes my estimates even more accurate and changes the work that I do inside each operator. Now that was a simple example with just one thing going on inside the query. Now let's make stuff a little bit more difficult. Now, let's say, let me go jump down a little further. Oops, come back over here. This set of queries. Let's execute these and I'm going to walk you through what it's doing. So here, what I'm telling SQL Server is go set up a variable, then set that variable to whatever our top location is. I'm ordering by count star descending. Whatever the most popular place is at Stack Overflow, as it turns out, it's India. When people fill out their location, the top location is actually an empty string because there's probably a lot of people with tinfoil hats on, like, I don't want my boss to know where I am. The top location, though, in here is India. So go find the top location and then show me all of the people in that top location. So there's a couple of parts to this query. The first part is when SQL Server does what we did in the last step. Go get me the top location from the users table. SQL Server goes, all right, yep, I got it. I'm going to first go through the entire locations index. I'm going to sum everyone up, ordered by how many locations they have. I'm going to group things together after I come back from parallelism. I'm going to find the very top one location, and then I'm going to set it to this variable right here. Then SQL Server is going to turn around and go find all of the users in that location. Well, you'll notice I did something kind of dirty here. I said select star. Now we have an index on location, but the only field it's on is location. It's not a covering index. which means that because my evil nasty query did select star, we're going to have to do a key lookup. And if you look at that output list right there, that's the list of all the fields that SQL Server has to go and get from that clustered index. And because my nasty evil query is sorting all of these people by display name, that's what this operator is right here, this sort, where SQL Server has to sort them all. So let's look in a little bit more detail at that bottom query, that select star. In that select star, SQL Server says, well, all I have to do is go seek on the location index to whatever the top location is. All right, SQL Server, how many users do you think are going to be in the most popular location? Oh, 91. 91? Where did you get 91? Well, you see, that's the average number of users in any given location. Because when I ran this query, I had no idea what the contents of this could possibly be. No clue. SQL Server, I just told you what the top location was. I told it to you right here. I said, go get the top location. I know, but when I built this query plan, I had to build the whole plan all at once. If I build the whole plan all at once, I don't know what that value is going to be until I go to execute it. Now, in fairness, I'm being kind of mean to SQL Server here, but I get that he couldn't possibly know what the top location would be until we ran this query. So it's fair that he wildly underestimated stuff. He estimated that only 91 rows were going to come back, when in actuality about 25,000 did. And then when people look at this execution plan and they see the key lookup, I wish these were three-dimensional. I wish they popped off the page in terms of the number of times that they were executed, because you look at that and you just think, oh, it's one key lookup. How bad can it be? But then you hover your mouse over it and look at the number of executions. Number of executions, this was done 25,000 times. So this is not a lightweight thing, SQL Server. Oh, I'm going to have to do this 91 times. Oops, my bad. I did it 24,000 times. And this data tsunami comes out where SQL Server just wasn't expecting 25,000 rows. And whammo, what do you know? We have to spill this thing to disk because we didn't grant enough memory at the time that this query ran. So how do I make my estimates more accurate on a query like this? When I have this select top one location, here's my batch. Now with cardinality estimation, in order to get accurate estimates, sometimes it's a matter of taking a large query and smashing it down into one tiny piece. Sometimes it's a matter of taking one single statement and tearing it apart into a lot of different queries. So let's try the smashing approach. Right now we have 3 different queries. Let's turn that all into one query. Let's tell SQL Server, hey, just go get the top location, and then using what you know there, go ahead and go get the people in that location. I'm not setting anything to a variable. I'm going to do the whole thing inside one pass and then execute it. So here's that query. Here's the select. Let's go get his execution plan. And look at that. Ugh, God, it's sprawled out all across the screen here. All right, let's decode this. From here to here is the top piece, is this part right here. This is where SQL Server says, go scan all of the locations, group them together, do that across multiple cores, group them together again, just go find the top one. And at this point coming out of here, we have one location and that's it. Now, you and I know that that one location is India. Then SQL Server is going to go seek directly to India in the user's index. Hover your mouse over this and look at estimated number of rows versus actual number of rows. Estimated number of rows is 13. Our estimate actually got worse. Our estimate got worse, not better. Before it was 91. Here it's 13. It's even worse. So of course, now we have our data tsunami coming in. This key lookup, SQL Server, oh, I'm only going to have to do this 13 times. Oops, my bad, I did it 24,000 times. And then as we continue to flow through this execution plan, here comes the data tsunami. Thought we'd only have 13 rows, we have 24,000, and oops, this sort has to spill to disk again. Now this is fair though, because SQL Server has to build this entire execution plan all at once, and it has no idea of what the output will be for this until it actually happens. Sometimes people will stick an option recompile on here, thinking, well, maybe I just need to get a brand new plan every time that this thing runs. But the problem is that this whole plan is all built at once, and SQL Server still has no idea how many rows are going to be coming into this sort operator. Now, remember how earlier I said sometimes the answer is to take a bunch of small queries and mash them together into one, like with this CTE? Well, sometimes the answer is to take a bunch of separate queries and then let SQL Server build a new execution plan at certain points. For example, what if I could tell SQL Server, yeah, first go get the location, go get whatever the top location is, and then when you know that, I want a new execution plan just for this part. When you get here, go build me a new execution plan for this part, and then you'll know what the contents of top location are going to be. Let's see how that works. Let's execute. And the first query is always the same as what it's been. I don't have any yellow bangs here. SQL Server understood roughly how many rows were going to come in and out. The first one has accurate estimates. The problem that I had has always been the bottom row. And the bottom row now has no yellow bangs. And it doesn't even use the index, which you might be saying, Brent, that's terrible. The bottom one used to be using an index on location. But now SQL Server knows that it doesn't make sense to do the seek plus a key lookup because there were so many key lookups it had to do. Now it knows, because we're looking at India, look at the estimated number of rows versus the actual number of rows. SQL Server has a much better idea of what's about to take place here, and it accurately estimates how much memory it's going to need for the sort. This doesn't spill to disk anymore. It's easy to get hung up and say, well, I'd really like to be able to use the index here, but given the number of users you have coming back, it doesn't make sense. This is your top location. It's India. You may end up doing a lot of key lookups here. So what I just showed here is the difference between a couple of different approaches. Sometimes it makes sense to use a bunch of small queries and then stick in a recompile hint when the stuff that happened previously is going to make a dramatic difference with whatever happens in the next phase of your query. Other times, it makes more sense to just bash the whole thing down into a single big query with things like a CTE or lots of joins. Just know that you're not going to have any idea of what's going to come out of here until the query runs. I can't just stick a recompile on the outer piece. Anytime that I find myself wanting to stick a recompile on parts of a query, I'm going to be better off breaking that query up into chunks and doing separate recompiles out there. Now that example we just did, it only involved one location. But let's make things even uglier. Let's take a temp table. Let's say with, oh, actually, let me do the CTE example first. Go get me out of the users table. Let me come all the way back. Where the hell did my CTE? Oh, no, that's what I want. Let's take out of the users table, go get me all of the users whose location is in the top 5 locations, not just the top 1 location, but the top 5 locations ordered by display name. Now, when I execute this, it's going to have the multi-branch execution plan. Remember, over here at the top, from this part over here to this part right here, this is involved in just getting those top 5 locations. There are no yellow bangs across this portion. The estimates versus actual are exactly correct. SQL Server knows how many rows are going to end up coming in out of this top. So we know that exactly 5 locations are going to come out. Now comes the tricky part. This is really confusing looking at the execution plan. That index seek, that looks like SQL Server is just once going to the location index, but that's not exactly true. If you hover your mouse over there, look at number of executions. Number of executions is 5. SQL Server is doing this index seek 5 times because we asked for 5 different locations. India, Indiana, Kentucky, whatever the top ones are. And then comes the interesting part. SQL Server, how many rows do you think are going to come back? Like 13. Maybe each time I go look, I'll find 13 rows. And here comes the data tsunami. We estimated that we'd find like 66 rows altogether. We found 69,000 rows, because SQL Server thought it was looking up 5 typical locations. It had no idea that we were purposely looking for the top 5 ordered by the most popular descending. Now, of course, you're looking at that query going, well, of course SQL Server knew it was the top 5. I just told it was the top 5. But SQL Server kind of thinks in isolation. It just goes, oh, I'm going to find, I don't know, 5 locations. I don't know if they have anything in common. They just happen to be 5 locations. It doesn't do any kind of extrapolation between this part of the subquery and this part of the subquery. It just sees that this guy is looking for 5 locations, and that's all he knows. So he picks 5 average locations and only estimates that 66 rows will come back. And then here comes the sad trombone. Because we were only looking for 6, or only expecting 66 rows, SQL Server's like, yeah, sure, I can do 66 key lookups. Estimated number of executions is 66 here. How bad can it be? Oops, my bad. Because we end up having to do this 69,000 times. And then as the data tsunami keeps flowing, 69,000 rows are coming into this sort. And you look at that execution plan's cost and you go, 0. 0 is a great cost. I like things that cost 0. But the estimates, those cost percentage that you see, even when you're looking at an actual plan, they're still only estimated costs. It has no idea in that 0% cost that we're actually dropping to disk and writing thousands of pages down to temp DB because we simply didn't estimate the right number of rows. So how am I going to fix this one? I can't just slap an option recompile. That's not going to help me at all here, because especially if I don't spell recompile right. If I just slap an option recompile on there, again, SQL Server builds this whole entire execution plan without having the foresight of knowing exactly how many rows are going to come out until it's way too late. Here, 66 rows are estimated to come out, and of course, we still end up spilling to disk. So this isn't going to cut it. I need a better way to break this query apart separately to have it get done. And then here comes the interesting part. And I say that a lot because I think a lot of things inside SQL Server interest the daylights out of me. I get absurdly excited about working with SQL Server on a Saturday night. I need some kind of way to tell SQL Server, not just that it's 5 locations, but I need it to understand what those top 5 locations are so that when it goes to do this index seek, it knows, oh, I'm looking for India. I'm looking for something that's extremely popular. So one way to do that is with a temp table. And here's what I'm going to go do. I'm going to start by creating a temp table. I'm going to load that temp table with the top 5 locations. And then in a separate step, I'm going to query that temp table and get that joined to users. And what happens now is kind of amazing. I'm going to go through and execute it. Now the first query plan, this is the first one, is the same as it's been here repeatedly throughout. SQL Server knows exactly how many rows are going to come out of this top operator. It knows how many rows are going to come out of the stream aggregate. This part is not a tuning problem. This part is what we were struggling with before. And I'm going to move up so that we can see more of this. Now, SQL Server is doing the scan of the top locations. Then SQL Server is doing this index seek. SQL Server, how many rows do you think are going to come out of this? Hey, now it's more accurate. It's not perfect, but it's more accurate. I'll take 11,000 as opposed to like 66 rows estimated. It's not great, but it's better. So now at least it's expecting 11,000 rows are going to come back. So now it has a better job of understanding how many key lookups it does, but it's still getting socked just a little by this data tsunami. It expected 11,000 rows to come back. In actuality, 69,000 did. And so now we end up spilling 1,000 pages to disk. It's better than 6,000 pages to disk, though. We're spilling less than we were before. So how did SQL Server know? Why did it know that temp tables, in this case, we're going to give it a better job of understanding how many rows were going to come back from different users? Normally, or from different locations. Normally, you get a lot of advice out there like, don't use temp tables. Temp tables are evil. Everything is evil. I mean, the only perfect fast SQL Server is when you're not running any queries at all. It's not like I can tell my users, don't run any queries at all, and everything's going to be blazing fast. Any tool can be problematic. You know, a screwdriver is problematic if you use it to chop ice cubes. There's all kinds of things that are problematic. But temp tables in this case give me a really cool edge. There's something coming out of this where SQL Server actually understands what's coming out of this temp table. And to show it to you, I'm going to have to do something kind of weird. What I'm going to have to do is switch over into TempDB. And then I'm going to have to go look at what is the name of my temp table that I'm using. And then SQL Server, show me the statistics that you have on that temp table. And SQL Server says, well, I know there are 5 rows in there. There's Bangalore, there's Germany, there's India, there's London, the United Kingdom, and there's the United States. Dang, this is even better than variables. SQL Server's tracking the rows inside this temp table and what their contents are. This is why when I run it with a temp table, SQL Server does a better job of guessing how many rows are going to come out. Whoops, I got to switch back over into the users table now. So this is where SQL Server does an even better job of understanding how many rows are going to come out because it knows what the contents of that temp table are going to be. Is it perfect? No, SQL Server still isn't budgeting quite enough memory in order to do that sort, but it's spilling less data than it was to disk because our estimates are closer than they were before. And of course, if I want to make them even closer, I can do things like cheating. I can say things like top 100. So that now, instead of using, if you look down at that memory grant in the pop-up tooltip, memory grant, this query wants 69 megabytes of memory in order to run. Now, instead of wanting 69 megabytes, it wants way less because I'm only asking for the top 100 rows. Now, it can get by with just 10 megabytes instead of like 70 megabytes. Anything I can do to influence the number of rows that we're working with can end up being a good thing in terms of predictability. Let me come back to the slide deck here. Let's pop back out over here. So what we covered in here inside the last hour, cardinality really involves 2 things. Number one, it involves predicting how many rows are going to come back. And this is the thing that most people think about when we talk about cardinality estimation, but it also involves guessing the contents of those rows. In the second phases of the demos, when I started grabbing the top 5 locations and even the top 1 location like India and using it as a second part of the query, When SQL Server knows what those values can be, it can build a way better, more high-performant execution plan. There are tons of ways that you can do this. But when I focus on tuning queries, I've got a totally free class out there you can watch called Watch Brent Tune Queries. I start comparing estimated versus actual, trying to get those as vaguely close as possible within, say, 10x. And there's lots of tools that you have at your disposal. You can update statistics, you can use option recompile, switch cardinality estimates. 2017 has new adaptive query processing to influence whether it does hash nested loop joins versus hash joins. I'm trying to remember if that's what it does. I think that's what it does. It's been a while since I've looked at that thing even, which tells you how often I use that thing in order to make stuff go faster. Because the problem with adaptive query processing is right now it only works in batch mode, which you have to have a column store index in your query in order to pull that off. So it hasn't been terribly useful for me. You can change the database, and by changing the database, I don't mean switching to Oracle. I mean changing out by adding in indexes or adding in statistics. I'll be the first to tell you that the thing I do much more often between those two is to add indexes, not as much to add stats. And then finally, sometimes the answer is to take a large query and to break it up into tiny chunks. Sometimes the answer is to take a bunch of tiny queries and just bash them together inside one giant query. There's no one right answer. You'll hear people debate, should I use a CTE or a temp table? Depends on which one's getting you the most accurate cardinality estimates. The more accurate your estimates can be, generally speaking, the faster your query is going to go. If you want to learn more, there's a great pre-con that Eric and I, of course, I'm biased and I think it's great. There's a great pre-con that Eric and I are doing at the PASS Summit in November in Seattle, where we're going to be doing 21 demos through the course of the day to teach you more about things like cardinality estimation, adaptive query processing, statistics, I/O, all kinds of stuff. Feel free to fire away with your questions over in the Q&A panel and go to webinar, and I'll go through those. George asks, the machine you used was kind of small. Hey, that sounds like a personal insult, George. If you had more hardware and cores, can SQL Server detect this and be more generous in its estimations? Well, George, hold on. Let's think about that for a second. So this VM, sure, this VM has only quote unquote 8 gigs of RAM. But dude, the query was spilling to disk even though it only wanted 7 megabytes, not gigabytes, but 7 megabytes. When you see, I'm going to jump way back up to the top. I'm going to drop my indexes so that I'm starting over. Then I'm going to go back to the very initial demo where I was doing the first one in SQL Server guessed incorrectly. If I go back here, and of course it's not fast, if I go back here and I look at the memory grant that this query wanted, this query only wanted 2.6 megs of RAM. It would give me the same estimate even if I was on an 80 core box with 3 terabytes of RAM. Desired memory is, in the best case scenario, how much would I be willing to use? And it's normal to see this be way more than your box even has for crappy queries. But here, SQL Server is just criminally underestimating how much work is required. It has nothing to do with how many cores you have or how much memory you have. It just thinks it's a lightweight query. Now, what you can see, I'll give you an example, or what you may see in production. I'm going to give you an example by making my query terrible. So right now, the display name field is only an nvarchar 40. I'm going to do something awful. DBO users, alter column, display name nvarchar 400. Let's make it 4,000 just for laughs. Then let's turn around and take that same thing, and I'm going to do it for location, which is nvarchar 100. And then I'm going to say same thing for website URL, which is nvarchar 200. Run that. Now I'm going to say select star from DBO users, order by display name. What's going to happen is that SQL Server is going to say, oh my God, that is, let me go get rid of those big fields. Go get rid of that. SQL Server is going to say, oh my God, what's coming out of this? It's going to be huge. This could be a whole lot of data. I estimate that 79 gigabytes is coming out of here. Well, wait, what SQL Server? Hold on. Let's look at the users table. How big is the users table? Dude, it's about 600 megabytes. It's less than a gig. It's smaller than a USB drive that you would throw away if a vendor handed it to you. So SQL Server knows there's only 620 megs, and yet SQL Server goes, oh my God, though, this could be 79 gigs coming out of here, because SQL Server sees our wildly crazy data types, and it's just multiplying the number of rows times a variant of the size of our data types. So sometimes SQL Server will wildly overestimate how much memory it needs. I'm going to copy and paste this out so that you can see and put the commas in. Oh, this is kilobytes. So if I put this in here, SQL Server is perfectly willing to take 104 gigabytes, 104 gigabytes of RAM in order to sort this data because it thinks there's so much of it. Now, when I go and run this, this is where if SQL Server thought I had some kind of big, giant, beefy machine, it would actually end up allocating huge amounts of memory. In my case, like 100 gigs of RAM in order to run this one query. It would help me to have a much larger machine, except this query isn't actually going to go any faster because it's only less than 1 gig of data. SQL Server is doing all of this just inside memory to begin with. Sri says, best practice is to allocate min and max memory. Will the SQL Server allocate more memory to this query if they are set up correctly? No, it makes no difference well, so let me be clear when I say that. So if I go over here to properties and I go to memory, so right now I'm only setting SQL Server's memory to 3 gigs. I could set it to 500,000, whatever I want. SQL Server will still only allocate a percentage of the actual memory that I have. If you want to learn more about the default amounts that SQL Server will use, I'm going to go sys resource. I believe it's under pools. So SQL Server has all editions of SQL Server. People usually think Resource Governor is a feature of Enterprise Edition, but even under Standard, SQL Server uses Resource Governor under the hood in order to help or manage how much memory queries get. By default, SQL Server uses Resource Governor in order to cap how much memory a query can get, a given running query can get in terms of workspace memory. And you can see more about that under, let's see here, U222, this could be workload groups. Nope. Yes, there we go. Perfect. All right, so it's the second query inside here, Resource Governor workload groups. It'll dictate how much memory any one query can get in terms of memory workspace. So by default, say that you have a server with 1 terabyte of RAM, one query just by itself can get a couple hundred gigs of RAM by default. So you may end up having to throttle that down. All right, well, thanks everybody for hanging out with me. I should put up, hold on, one more slide. So if you want to come out and hang out and learn more from us, by all means, come join us at the PASS Summit. We have a hoot with that. There's already over 150 folks signed up. And then thanks for hanging out with me on a Saturday night. Adios, everybody. Have a good weekend and enjoy.
Thank you.